Hello everybody, welcome to the videos for the cumulative review packet number 13. Let's start here with number 1, where I'm asking you to graph the following quadratic equation. Quadratic, again, meaning something like x to the second power. We would like to graph this using the x-intercepts, the vertex, and the y-intercept, and a table only if you need it. So if you need extra points, then you should use a table. Otherwise, I'm looking for you to understand the roots, vertex, and y-intercept. So as a first reminder, if you'd like to find the roots or the y-intercepts, that is along my x-axis, which means that y is 0. So the first thing I would do is plug in 0 for y into my equation, and then I would decide if I can factor this, and if not, I could use the quadratic formula. So if I look at this quadratic and I try to factor it, a times c negative 6, and then I list my pairs that multiply to be 6, neither of these can combine to be a negative 8, which means that I cannot factor this, which means I have to use the quadratic formula instead. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals positive 8 now, plus or minus the square root. Negative 8 squared is 64. I see a double negative, so it's a plus 4 times 2 times 3, which would be 24, all over negative 4. So far, we have x equals 8 plus or minus the square root of 88 all over negative 4. And yes, we could split 88 into a perfect square and a knot, but because I'm doing the quadratic formula to find roots, let's go ahead and find the decimal approximations now. So if in the calculator I type in 8 plus the square root of root 88 over negative 4, that answer would be about negative 4.35. And if I do 8 minus the square root of 88 all over negative 4, that would be approximately 0.35. So my roots are not perfect, but that's okay, and I'm going to write them in the blanks over here. So one x-intercept is negative 4.35 comma 0, and the other root or x-intercept is 0.35 comma 0. So I'm going to do my best to graph those 2 points. Negative 4.35 is somewhere in the middle of negative 4 and negative 5, and 0.35 is between 0 and 1. So there are my 2 roots. The next thing I'd like to do is find the vertex, and the vertex is where the parabola turns and is always in the middle of your 2 x-intercepts. So if this is x-intercept 1 and x-intercept 2, I'm going to find the average or the exact middle between these 2. So you take negative 4.35, add 0.35, and then divide by 2. That would get me negative 4 over 2 or negative 2. So my vertex so far has to be at the point negative 2 comma something. And again, to find that something, you'd need to take the negative 2 and plug it into the original equation. It's for x. So that would be negative 2, and then x is negative 2 squared, minus 8 times negative 2, plus 3. If I follow the order of operations, I would do the exponents first. So I get negative 2 squared is 4 times negative 2, negative negative, plus 16 plus 3. So this is really negative 8 plus 16 plus 3, which would be 8 plus 3, or 11. So my vertex is at the point negative 2 comma 11, which goes off our graph a little bit, but that again is okay. So if I graph that, negative 2 up 11, it's going to be just off the graph because here's 10, so 11 will be 1 point higher. The last thing I need to find to graph my parabola would be the y-intercept. And the y-intercept is on my y-axis over here, which means that x is 0. So if I take 0 and plug it into my original equation, so that circled red one up here, that would be negative 2 times 0 squared minus 8 times 0 plus 3. When I plug in 0, I love it because things just disappear, because this ends up being 0 minus 0 plus 3, so I'm left with 3. So my y-intercept is plug in 0, get out 3. And if I come up to my picture and I plot the point 0, 3, and look at the parabola as a whole, I expect it to be a parabola, and I like that it looks like a parabola that's going to be upside down because in my original equation I have a negative in front, which means that the parabola should be flipped over. And so if I connect all those points, I would have my parabola shape through the x-intercept, turning at the vertex, through the y-intercept, through the x-intercept, arrows pointing downwards. Now that I have this picture, my axis of symmetry is the line that cuts the parabola in half. And that hits the x-axis at -2, so the vertical line would be x equals -2. Is the vertex a max or a minimum? Well, the vertex is the very top of the parabola, so it has to be a maximum value. The next two things are the domain and range. The domain, you're covering everything to the left and everything to the right. So your domain would be -infinity to +infinity for a parabola. My range, however, is a bit unusual. The range is from the bottom to the top. So my parabola starts down here at -infinity, and then the very top value of my parabola would be up here, because remember the vertex is -2, 11, so it goes up to 11. So my range would be -infinity, sorry about that, would be -infinity to 11 with a bracket. Numbers 2 and 3. These functions are given in vertex form. Unlike number 1, this is given in standard form. Whenever you're given something in standard form, that's when you need the roots, vertex, and y-intercept. But if you are given in vertex form, that means you can see the vertex right away. So if I looked at number 2, I notice it's squared, so I know it's going to be a parabola. I notice that there's a negative in front, which means that I'm eventually going to have an upside down parabola. If I think about direction, the x plus 4 is always opposite of what you think. So this parabola is going left 4 units, and the -3 means I'm going down 3 units. So if my parabola starts at 0, 0, I'm going to go left 4, down 3, and I'm going to start my parabola here. And now I need to follow that pattern that's true for every single parabola. You might remember that the pattern looked something like this: 4, 1, 0, 1, 4, because you take these values and plug it into x squared. So from my green dot, and because this flipped upside down, my pattern would go like this: over 1, down 1, over 1, down 1, from the vertex, over 1, 2, down 1, 2, 3, 4, from the vertex over 2, 1, 2, 3, 4. And so my parabola would look like this. I wish it looked a little better on this screen, but that is a good enough sketch. Number 3 is the same idea, except this is an absolute value equation, which means in the end I'm going to have a v absolute value, and I'm not going to have a u. Because there's no number in front, or really no negative in front, my absolute value is being facing up. If I think about movement, if I see inside x minus 2, that means I'm moving to the right 2, and the 5 means I'm going up 5. So from 0, 0, I would go right 2, up 5, put a dot here representing my vertex, and then from there, my points would be over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, because we want to make a perfect V and not a U. So this would be my answer for number 3. And if you'd like to write yourself a note, feel free. The vertex on this example then, if you're going left 4 and down 3, will be at -4, -3. And the vertex of this absolute value equation, because we went right 2, up 5, would be at 2, 5. The next example, sticking with a lot of graphing at the beginning here, is a graph of an exponential function because it's a base to a power. And this is what we did back in chapter 7, but I keep putting it on here to help you again for the final exam. So we have a table given to us, so let's plug and chug. It would be -3 to the -2nd power minus 2, 3 to the -1st power minus 2, 3 to the 0th minus 2, 3 to the 1st minus 2, and then 3 to the 2nd minus 2. If we start at the bottom, this is really 9 minus 2 or 7. This is really 3 minus 2 or 1. 3 to the 0th is 1 minus 2, which would be negative 1 is my output. 3 to the negative first, remember, does not cause negative numbers. It causes reciprocals or fractions. So this is really 1/3 minus 2, which as a decimal would be about negative 1.67. And then this first one, 3 squared is 9. So 3 to the negative second would be 1/9 minus 2, which as a decimal is negative 1.89. And so if I plot all of these points, negative 2 comma negative 1.89 would be really close to negative 2. Negative 1 comma negative 1.67, a little bit higher. 0, negative 1 right here. 1 comma 1, and then 2 comma 7. The graph, as you may remember, when you have an exponential function, it increases really quickly, but it starts flat. So the graph starts slowly and then increases exponentially, hence the name exponential function. So just make sure that these points are very apparent. You'd have arrows going both ways. And again, remember that this function looks like it is not crossing this line right here, so I'm going to put an asymptote in right there. So my answers would be the following. Does this have a y-intercept? Yes, it crosses the y-axis here at 0, negative 1. I can also see that in my table. Do I have an asymptote? Yes. The line that this exponential function gets close to but not crosses is y equals negative 2. It is a horizontal line, which is why it's y equals negative 2. Unlike the first example, if it's a vertical line, it'd be x equals. The domain of this function, just like a parabola, is negative infinity to positive infinity because it never ends both directions. Then the range of this function, the lowest point that I start is here at negative 2, but negative 2 is not included. So you'd have negative 2 with a parenthesis, not a bracket, and then the function goes up towards infinity. Does the graph above represent exponential growth or decay? I would say exponential growth because from left to right, the function is increasing rapidly. If we take a look here at number 5, 5 is a piecewise function, and just like in class, I would suggest to use a table to help you, and we're going to answer these questions once we're done with the graph. The first part of this piecewise function is x squared minus 4, and because it's x squared, I expect it to be a parabola, but this parabola only exists greater than or equal to negative 1. So if I make a quick little table, I start at negative 1, and then greater than or equal to negative 1 would be values like 0, 1, and 2. So if I take all these values and plug it into the function x squared minus 4, I would get negative 1 squared minus 4, 0 squared minus 4, 1 squared minus 4, and then 2 squared minus 4. So this would be 1 minus 4, negative 3, 0 minus 4 is negative 4, 1 minus 4 is negative 3 again, and 2 squared minus 4 is 0. So if I plot all those points, I should make sure it looks like a parabola, at least part of one. Negative 1, negative 3 is down here, and negative 1, negative 3 is a closed dot because this is greater than or equal to 0, negative 4, 1, negative 3, and then 2, 0. So this piece of the parabola would start at negative 1, 3, and then it's greater than or equal to negative 1, so it's going towards infinity this way. So only this piece of the parabola exists. And you do need an arrow at the end of it because it does exist from negative 1 all the way to infinity. So there's part 1. Part 2 of the piecewise is a line, 2x plus 3, but it only exists when x is less than negative 1. Just like the red graph, we do want to start with negative 1, but this will just be a hole when we graph it. Less than negative 1, some values would be negative 2, negative 3, negative 4. And if I plug these into 2x plus 3, I would get 2 times negative 1 plus 3, 2 times negative 2 plus 3, 2 times negative 3 plus 3, and then 2 times negative 4 plus 3. I'm going to pause here because I don't have enough time in this video. However, I will pick up where I left off with number 5 at the beginning of video 2. Thanks, guys.